Hello, this is Information Service Engineering, lecture number 3, Linked Data Engineering. In this part of the lecture, we are going to talk about how to model buildings with RDFS. And let us start. So, the question here is, what do we see in this slide? Can you understand what we see in this slide? Well, let's see. So, what do we have here? We have a URI, which ends with the word Pluto, and then we see a picture of a planet behind it. Okay, so we understand this is a planet. And then we have another URI, this Charon moon, again, a planet behind it. So, okay, another planet, and a relationship between them, the satellite of. So we say, okay, then the Charon moon is satellite of Pluto. Pretty simple. And then another relation, the relation discoverer, which links Pluto to a person, for which we have a name here and a picture. So, okay, pretty simple. We know what is the information hidden in these triples by using the figure as well. So, no problem. But, well, let's go deeper and see if there is actually a problem here. Okay, now we have only one of those two triples we saw before. Still, one could say, fine, what do we see here? Two entities linked through a property. And we know that those URIs are actually the identifiers that we have for those entities here. And still one could say that we can say what the information we have here, what is the information represented. That Pluto has a satellite, this Charon moon, since this, we have the property satellite of between them. Still everything is fine. Well, let's see. Because actually the same information could be represented by using a completely different identifier. Something that ends with an actual ID in the end and not with the word Pluto or Charon moon or satellite of, which we as human, we can make sense out of it. So we could have the same information represented with URIs ending with something like Q142 or Q144 and Q141. Then, what can we do? Can we still say that we know what this information really means? Well, I think no. So, the solution here is, and that we need more semantic expressivity. And where are we going to find this semantic expressivity? So here is a familiar picture to you. Here we have again the semantic web technology stack we are going to revisit. And in this part of the lecture, and in order to have this expressivity we are going to use this yellow building block there where all these models, all RDFS and SCOs are. So in this part of the lecture, we are going to emphasize more into the RDFS or RDF schema, as it's called, to find the expressivity we need. So RDF schema officially is called RDF vocabulary description language. And here the RDF schema allows the definition of classes via the RDFS class. And there we can have instantiations of those classes. And to have that, we are going to use the RDF type property. And let's see an example. So what can we say here is that planet is of RDF type RDFS class. And this is how we define that something is a class. And then to have an instance of this class, we do it in the following way. So Earth, another entity, is RDF type planet. So we have the planet, which is a class, as we defined it in our first triple, and then an instance of this class planet, which is called Earth. And let us see what else we can do in RDF schema or RDFS. So here we can define properties as well, via the RDF property. And to define properties, we can also restrict the domain and the range of those properties via the RDFS domain and the RDFS range. So restriction here means that we are going to specify from which class are they going to have subjects and objects, those properties. And let's see it through an example so that we make it clear. So what do we see here in the first triple? That celestial body is RDF type of class. We define a class. And then satellite of is RDF type of RDF property. So we define also a property here. And then what we want to do, we want to restrict the domain of this property we just created. And we do it in the following way. So we do satellite of RDFS domain celestial body and RDFS range celestial body as well. So what does this mean? It means that this property we just defined, the satellite of, can have subjects and objects which both belong to the class celestial body. And let us continue. So what we want to say here in this point is that in RDFS, everything in RDF model is a resource. And we model it in the following way. We say that RDFS class is of a type resource, and then the RDF property is also type resource, as well as the RDFS literal, the RDFS XML literal, and the RDFS data type. Everything is a resource here. And then let's go to the definition of hierarchical relationships. So RDFS allows us to define hierarchical relationships, both for classes and for properties. Let's start for the hierarchical relationships for classes. So what does this mean? It means that we can have subclasses and superclasses here. This is the hierarchy that we define. And this we do it via the property RDFS subclass of. So let's see an example. So here we see that planet RDFS subclass of celestial body. So it means that planet is also a class, probably was defined a bit earlier. And what do we say here? We specify that planet is subclass of the celestial body. And this is how, to make it easier to understand, if celestial body is the big circle, then planet is a subset of it. So this is what subclass of means. And we have the same hierarchical relationships between properties this time. So we can have subproperties and superproperties, and this we achieve it via the RDFS subproperty of. And let's see an example. So we have here the artificial satellite of, RDFS subproperty of, satellite of. So it means that we have here two properties, the artificial satellite of and the satellite of, and one, the first, the artificial satellite of, is subproperty of the satellite of. So, as we said before, we have the RDFS resources here, and everything is a resource. So, you see here that all literals, classes, data types, and the property, everything is a resource, is an instance of a resource. And then we see that for the property, we have all those nice properties here that we will widely use, like the RDF type, the RDFS comment, the RDFS subclass of, the RDFS subproperty of, RDFS domain, and the RDFS range, which all of them are instances of the RDF property. And what is left the XML literal, which is a subclass of literal and also an instance of the data type. So this is just an abstraction here of how all those resources are related to each other, so that you have an idea. But if you are interested in more details about it, you can visit the link in the right corner of the slide and get more information about it, the relations they have. And let's see some more properties that we have here in RDF schema. So we have the RDFS see also property, which defines a relation of a resource to another resource, which explains it further. So if we want to add a further explanation, we can say that, okay, see also this other resource as well that explains the first one. Then we have the RDFS is defined by, which is a subproperty of the RDFS see also, and defines the relation of a resource to its definition. So this is clearly the definition and not just an explanation. Then we have the RDFS comment, which is just a comment we put, or a usual text to comment something about a resource. And last but not least, we have the RDFS label. This is a very widely used property. It's the readable name of a resource. Contrary to the ID, to the URI, which in most of the times we cannot make sense out of it, we have here the RDFS label, which is the readable name of it. So in case of Pluto, if we had this URI that ends with Q144, the RDFS label here would have been Pluto. And let us see a full example here. So this is a part of an ontology in RDF. First, on top, we have defined our prefixes, which we are going to use next in the ontology. And then, first, we have the class definitions. So what do we see here? We see that we have planet, which is a class, and then we define that is subclass of celestial body. And then we have satellite, which is again a class and subclass again of celestial body. And then in the end, we define artificial satellite as being a class and subclass of satellite this time. So here we have our class definitions and the hierarchical relationships among them. And then we continue to the property definitions. First, we have only one property here, which is called satellite of. We defined it as being a property, and we restrict both the domain and the range of the property being celestial body. So that means this property holds between entities that are of the type celestial body. And then we have the instance definitions. So here we have Earth, which is type of planet, and then Moon, which is type of satellite, and is also a satellite of Earth. So we define those two instances as being types of two different classes, and then the relation between those two instances. And then in the end, we have our last entity, which is called Sputnik 1, which is type of artificial satellite. So this belongs to another class this time. And again, there is a relationship between the Sputnik 1 and Earth, since the Sputnik 1 is satellite of Earth. And we see some more properties here about Sputnik. We see the RDFS label of it, and you see that in quotation marks we have the readable format of the name, and then the specification that this is in English. And last, we have the RDFS comment, so just a comment about this entity, and the comment says the first artificial Earth satellite in 1957. So this is a full example of an RDF ontology where we have first our prefixes, we defined our classes and the hierarchical relationships among them, the property, and then instances of those classes and how they are related. So in the next part of the lecture, we are going to talk about logical inference with RDFS.